Deep-sea creatures have evolved unique adaptations to survive in extreme darkness and pressure. Since sunlight doesn't reach the deep sea, many creatures produce their own light through bioluminescence. These animals have special light-producing cells called photophores, or they host bioluminescent bacteria inside their bodies. This helps them attract prey, communicate, and camouflage themselves. For example, the firefly squid flashes blue light to confuse predators. At extreme depths, the pressure can be over 1,000 times greater than at sea level. Many deep-sea animals have soft, gelatinous bodies instead of hard bones, making them flexible under pressure. They lack lungs or swim bladders, and their bodies contain pressure-resistant proteins. The Mariana snailfish was found at 8,178 meters deep, surviving in extreme pressure without bones. At deep-sea levels, temperatures can drop to 1-4 degrees Celsius. Some fish have antifreeze proteins that prevent ice crystals from forming in their blood. Many deep-sea creatures move and grow very slowly to conserve energy, and thick layers of fat or gelatinous skin help insulate them. The ice fish in Antarctica has antifreeze proteins that keep its blood liquid. There are no plants in the deep sea since photosynthesis isn't possible. Deep-sea creatures get food from marine snow, hunting and scavenging, or symbiotic bacteria. The Azidax worm, or bone-eating worm, survives by digesting whale bones. Giant tube worms host bacteria that convert chemicals from hydrothermal vents into energy. In total darkness, survival often depends on hiding from predators. Some deep-sea fish are almost completely invisible, while others use red or black coloring to camouflage themselves. The gulper eel can expand its mouth 10 times its normal size to scare off predators, and the profish hides inside sea cucumbers. Despite the darkness, crushing pressure, and freezing temperatures, deep-sea creatures have evolved in remarkable ways. Their survival proves that life can adapt to the harshest conditions. This raises the question, could similar life forms exist in the dark, high-pressure oceans of Europa, Jupiter's moon? Scientists believe the answer might be yes.